Hello everyone, welcome back to my channel From Root to Best. Today we will talk about another interesting problem, that's Josephus problem. So what's Josephus problem is, uh, let me just show you with an example, okay? So for example, let's say we have some people standing on a circle, and person standing on the first position has a sword with him. Now what he will do, he will basically kill the immediate next person and pass the sword to next alive person, and then that person will again kill his immediate next person and pass the sword to next alive person, and so on. This process will go until and unless only one people is alive or will be alive. So now the problem is, who will be that lucky person that will be alive after being killed by other persons, right? So that's what Josephus problem is all about. Now, so for example, let's say we have 10 people standing in a circle, okay? And the person one has the sword in his hand, okay? Now, let's say person one, he kills person two and pass the sword to person 3, right? Now person 3 will again kill the immediate next person, so person 4 is killed and he passes the sword to person 5. Person 5 will kill person 6 and pass the sword to 7. Then 7 will kill 8 and pass the sword to 9. 9 will kill 10 and pass the sword to 1. Again 1 will kill 3 and pass the sword to 5. 5 will kill 7, pass the sword to 9. 9 will kill 1, pass the sword to 5. And finally 5 will kill 9, right? So after getting killed by immediate previous persons, the fifth person will be the winner and he will be alive at the end of the entire process, right? Now if we try to solve this problem using brute force, right, what will be the solution? Solution is going throughout the circle one by one, eliminating one person at a time till only one person left, right? So if we let's say, let me write here, let's say if we try to solve this in brute force, right? So what we will have, let's say we will have a list of all the peoples, okay? So let me just have a list, okay? People, okay? And for now let us assume that it has 10 peoples, okay? I mean, I know this is not the correct syntax for list definition, but just assume that currently we have 10 peoples in this list, okay? Now what we will do, we will keep on doing the same process like till the last person alive. So let's say keep eliminate or keep killing. So let's not use the word killing, let us use eliminate, okay, every next person, okay? Now, so how we will do that? We will have a while loop where we will check if people list size is greater than 1, right? So we will loop through until the people has more than one, or the list of people has more than one person alive, right? What we will do here, we will simply calculate the next uh, available person index, right? So next available person index is current index plus 1 and this will be modulo by the remaining people's size or remaining person. Okay, and then we will simply remove that person from the list. Okay, and at the end we can return the single person present in the list, that is index 0 value. Correct. So till now this solution looks perfect. Okay. Now the problem here is the complexity of the approach we have used to solve this problem, or the brute force approach we have used, right? Because we will anyway looping through the entire list. Okay, so it will be equals to order of n. Correct. So time complexity of this approach would be order of n, order of number of persons present in the circle. Right? Or time complexity. Okay. Now, can we solve this problem in an optimized way, or can we try to solve this problem? Let us try. So in order to find the optimized solution, we have to find a pattern, right? So what could be the pattern here, right? So let us try finding a pattern in this problem. Okay, so for example, let's assume if there are only two people standing on the circle. Okay, so what will be the result? Okay, if there are only two people, so first person will have the sword, he will kill the second person, and only person will be alive is the person at the first position itself, right? So in this case the answer will be person 1. Correct. Now similarly, if there are three people standing on the circle, okay, so what will happen now? First person has the sword, he kills the second person and passes the sword to third person, and third person will kill the first person and he will remain alive, right? So winner will be person 3. Correct. So here if we have three people, the winner is person 3. Correct. Now if we, what will happen if we have four persons in the circle? Okay, so let us take this example. Person 1 has the sword, he will kill second person, passes the sword to third person, third person will again kill the fourth person, passes the sword to first person, and he will kill the third person. So in this case person 1 will be winner. So if we have four persons in the circle, the winner will be person 1, right? Similarly, what will happen if we have five persons on the circle? Let us check this as well. Person first, he will kill second, passes the sword to third, third will kill fourth, passes the sword to fifth, fifth will kill first, passes the sword to third, and third will kill fifth. So person 3 will be winner this time. Correct. Again, now the number of people, if 5, then person 3 is the winner. Similarly, what will happen if we have 6 persons, right? Again, 1 will kill 3, passes to third, third will kill fourth, passes to fifth, fifth will kill sixth, passes to 1, 1 will kill third, passes to fifth, fifth will kill 1. So fifth is winner here. Correct. Let me write this here. Okay. person fifth is winner when we have 6 people, right? Now again, if we have 7 people, who will be the winner? You can pause the video and try finding the solution, or try finding what position a person will be the winner. Okay, so first will kill second, pass to third, third will kill fourth, pass to fifth, fifth will kill sixth, pass to seven, seven will kill first, passes to third, third will kill fifth, passes to seven, seven will kill third. So position 7 is the winner this time. Correct. Now let me quickly write here this as well. So person 7. Okay, and what will happen if we have 8 people, right? Again, one will kill second, pass to third, third will kill fourth, pass to fifth, fifth will kill sixth, pass to seventh, seventh will kill eight, pass to one, one will again kill third, passes to seven, seven will kill, sorry, passes to fifth, fifth will kill seven, passes to one, one will kill fifth. So position 1 is the winner, right? Here person 1, right? Now can you see the pattern here? Let me just zoom out a bit. Okay, and scroll up. See, when we had 2 persons, person 1 was winner. When we had 4 persons, person 1 was winner again. When we had 8 persons or 8 people, person 1 is the winner again. So every time, if you can see the pattern, 2 4 sorry 2 4 and 8, right? In all 3 cases, person 1 is the winner. So we can clearly say, or let me summarize this every points here so that you can understand it better. Okay, so for 2, 1 is the winner, right? For 3, who was the winner in case of 3 person? Person 3, right? 3 is the winner. On person 4, again 1 was the winner. 5, when we had 5 people, person 3 is the winner, right? And 6, 5. Okay, so 3, sorry, my bad. 3 is the winner, then 6, 5 is the winner, 7, 7 is the winner, and 8, again 1 is the winner. Correct? People 1 winner, right? Similarly, people 3 is winner, right? What is the pattern here? Whenever the number of person is a power of 2, or number of people is equals to any value which is a power of 2, always the first position, the person standing on the first position is the winner. So for any number, if we can reduce that number to a value which is equals to power of 2, then on the position where it will be reduced, we can clearly say that position will be the winner. Okay, so for example, let's say, I will give you example. Let's say we have 10 people on the in the circle. Okay, now if we have to reduce 10 to power of 8, what would be the maximum power of 2 value we can get, which is less than 10 or equal to 10, is 8, right? So for 10 people, yeah, here, so 10 people, okay, now 8 is the power of 2, that is 2 power of 3, right? So in order to reduce 10 to 8, what we will have to do? We will have to kill at least 2 people. So 2, or let me write this way, 2 people needs to be killed, correct? If we kill 2 people from the 10, so remaining 8 peoples will be in the form of power of 2, correct? Now let's come here. First example. We have 10 people, right? Let me remove the cross marks. Okay. So in order to reduce it to power of 2, we have to kill 2 people, right? So who will be the 2 people? So person on the second position and person on the fourth position, right? So if we kill 2 people, one has killed second, passes sword to third, third has killed fourth, passes sword to fifth. Now the fifth position person has the sword, and total number of people alive in the circle are 8. So if we can consider the 5, now the 5 is the starting position where the total number of people is 8. By our observation, we can clearly say that position 5 person will be the winner, right? If we start the game from here, where fifth position person has the sword and total person alive in the game right now is 8 or power of 2, it will always be the person 5 who will be the winner, right? So that's the pattern we have to follow. So what we will have to do first, we will have to find what's the maximum number value, power of 2 value possible with the people available in the circle. Then how many people we have to kill to get to that value, and next what will be the position of that person after killing that many that many people, right? So we don't have to go through the entire list of the people. We just have to first find the power of 2, then kill the minimum persons or minimum people required to reach that value, and after killing that many people, whichever person is holding the sword, that person will be the winner, correct? Okay, now let me tell you the formula, right, to find the people. So what we are doing, we are basically killing the person and jumping to the next. So always we are jumping 2 and plus 1, right? Position is plus 1. So the formula will be here. Okay, so let's say we have n number of people, okay, and the value power of 2, okay, so 2 power of x, let's say x is equals to L, okay, where L is less than or equal to n, okay. If this is the scenario, then after killing that many persons, so what will the person needed to be killed? Person needed to be killed is n minus L, right? That many person we have to kill to reach that value, correct? Okay, now to get the position of the person after killing this many n minus L amount of people, we just have to use this formula, 2 multiplied by n minus L plus 1. Okay, let us see formula actually help us to find our winner or not, right? Okay, Okay, so here, my bad, sorry. We have 10 people, so n is equals to 10, right? And what's the value of L? L is 2 to the power 3, that is 8, which is less than equal to n and power of 2. So n minus L, that is 10 minus 8, is equal to 2. And 2 into 2 is 4 plus 1, that is 5. So for this example, our formula will return number 5. And by seeing the example also, we have observed the winner will be number 5, the person standing on position 5, right? Quickly, let me try with some other numbers, okay? Okay, so for 10, we have already, sorry, here, right? Let me write it here. So our formula, what we derived was, if n is equals to 10, so L is equals to 2 to the power 3, that is 8. So winner will be 2 into n minus L plus 1, right? Okay, so let us do this. So 2 multiplied by, or let me use multiplied by 10 minus 8 plus 1, which will be eventually equals to 2 multiplied by 2 plus 1, which will be equals to 5. So if we have 10 people, it will be 5. Okay, let us see whether this formula still works with other numbers. Okay, so for example, let's say we have 12 people on the circle. Okay, so here n is 12. What's the maximum value of 2 to the power n we can get with the 12 people? 8 again, right? Because 2 to the power 3 is 8, 2 to the power 4 is 16, which is greater than n. So we have to take L's value as 8. Now, if we put the values here n will become 2. So it will be 4 and the final answer will be 9, right? So if we have 12 peoples, our winner should be the ninth person, right? Now let us see whether it holds true or not. Okay, so let me just bring it here. Let us do our brute force approach here one by one. So person 1 has the sword, he will kill 2, passes the sword to 3, 3 will kill 4, passes the sword to 5, 5 will kill 6, passes to 7, 7 will kill 8, passes to 9, 9 will kill 10, passes to 11, 11 will kill 12, passes to 1. 1 will kill 3, passes to 5, 5 will kill 7, passes to 9, 9 will kill 11, passes to 1, 1 will kill 5, passes to 9, and 9 will kill 1. So finally 9 is the winner. So our formula or whatever we have observed is actually giving us correct result, right? If you can think of the yeah, so that's the formula. Now let me quickly show you the correct code in Java that will be used to solve this problem. Okay, so be with me here. So we have this class where we will write the solution for this Josephus problem. Okay, now Josephus problem. Okay, so let me quickly write the method. I am writing static method because I will directly call it from main method. Okay, it will return us the position of the winner person. Then let me Josephus. Okay, what it will take the number of person or number of people standing in the circle. Okay, so first we have to find the highest number or power of 2 value which will be less than or equal to n, right? So let me write a method, or let me write find power of 2. Okay? Let me name it as L power of 2. I will, sorry, of 2. I will create a method, okay, static method, and again public static int power of 2, which will take the number of people again, right, and it will return me the power value, correct? How we will do that? Okay, for now I am just writing a basic function that will calculate the power of 2. So simply I will initialize the power as 1. Power of 2 value is 1 because maximum 2 to the power 0 will be 1, right? Next I will check if power multiplied by 2 is less than or equals to n or not. If it's less than equals to n, till then only we will loop and calculate the power. So power will be into equals to 2, correct? And the moment it breaks the loop, we will simply return the power value. Okay, so we have got the power of 2. Now we just have to simply do this: return 2 multiplied by n minus l plus 1. Okay, two-line solution will help us to find the winner person in this Josephus problem. Okay, we don't have to look through the entire person list and all. So our complexity will be reduced to log of n. Why log of n? Because every time we are actually, so only loop here you can see is while we calculating the power of 2, and this power of 2 is actually getting increased twice of size every time. That's why the complexity will be log of n. Okay, now let me quickly write main method and I will call this solution. Okay, so string, okay, let me have int n equals to 10. Okay, now okay, so winner from n people will be this, right? Okay, so let us run this program. So if we have 10, it will be number 5 that we have already seen, right? Similarly, if we have n's value is 12, then the winner should be number 9, right? Yeah, so our solution is actually working perfectly and it's returning us the correct result. Just to be sure, let us try with the values where n's value is equals to power of n, power of 2's value, right? So if we give 8, it will give me answer as 1. If we give 4, then also it should give the answer as 1. And if we give 16, or let me use 32, then also the answer should be 1, correct? And the moment we will change, let's say 31, the answer will also be changed, correct? So that's how the solution works. Now let me give you some tricks, okay? Instead of calculating power this way, we can also optimize this and use some bit operations, bitwise operations to find the power, okay? For example, one thing we can do here is we don't need this, okay? We can simply change n. How? Let me show you. We can do bitwise AND operation. I hope you are aware of bitwise AND operation. I mean, what bitwise operations are and how it works. If not, please do let me know in the comment. I will create a separate video altogether where I will explain all the different types of bitwise operations like bitwise AND, bitwise or XOR, and in fact the shift operations as well. I will prepare the dedicated video for that. Okay, for now just let me use this again, n and n minus 1. Okay, and at the end we can simply return n. Now this will also work. First let me run this solution just to show you whether it's working or not, right? So here you can see we got the result. Okay, so let us change let me change the value 32 here. It's working fine. Okay, if we use 16 1 again, if we use 10, then it should be 5, right? So instead of calculating power that way, we can also use the bitwise AND operation. This will work much faster and it will also give us the same result, right? How it's working, if I try to explain, the video will be very long. Just let me know in the comment. I will definitely explain the entire calculation, entire bitwise calculation here, which will help you to understand this while loop in much better way. Okay, for now just remember this formula. This is also help us to find power of 2, which is less than equals to n. Okay, now one more thing we can do. Instead of this power of 2, we can use a built-in function from the integer class, integer wrapper class. Okay, so we can do integer dot highest one bit of n. Okay, so what it will do, it will so let's say one n's value is 10. Okay, so if n's value is 10, what will be the binary representation of 1? 1010. Now highest one bit means it will take the highest, this first MSB of 1 only, and rest it will take as 0. So this will automatically become 1 0, and then integer value of this is 8. Okay, now this holds true for any integer number. So if you want to take, let's say 31 or 32. 31, so what's the binary value of 31? 31 is, I guess, 5 times 1, right? Because the moment we will use 32, it will become 1 then 5 times 0, right? So this is the binary representation of 31. Now highest one bit means it will automatically replace the other bits with 0, and this value is 16, right? So for 31 it will, the n value will be 16, right? So that's how this entire function, I mean entire power calculation functionality, we can replace this one function call integer highest one bit n. Okay, and also this one also, to calculate it faster, we can replace it with bitwise shift operator. Okay, so what we can do here, we can simply n minus l, right? Then instead of multiplying it by 2, we can shift them one bit left. Okay, and then +1. Why one bit shifting to left will work? Okay, let me again give you examples. For example, let us assume that our L value is 1, which is 101. Now, if we shift this 1 to left, that means additional 0 will be added here. Now, what this value is becoming? It's becoming 10, which is double of 5, right? If we take any number, let's say 91001, right? Again, if we add 10 here, it will automatically become 18. 16 plus 2 is 18, right? So instead of doing normal arithmetic operation, we can use a left shift operation by 1 bit, which will automatically double the value of the correct integer and then add 1 to it. If you can see the exam, whether it's working or not, let me run this. See, it's working. If we change the value to 12, so it should return 9, right? 9. If we change it to 32, it should give us 1. Yeah, 31, it should give us what? 31? 31 only, right? So this solution is also working. So you can use whatever you want. This will not be tested during interview. You can use a simple power of method, and then instead of this AND operations, you can use normal power calculation, what we did earlier, multiplied by 2. And then here also, instead of shift operation, you can use 2 multiplied by this value. Okay, so anything you can use, but this solution of Josephus problem, I hope the explanation what I give you will help you to understand Josephus problem and to find pattern, how we can find pattern so that we can improve or we can optimize our code from brute to best. Okay, so if this video helps you, please like this video and share it with your friends, and also please subscribe to my channel. I will prepare, or I will keep on uploading such interesting problems with proper explanation and how you should think or how you should approach any problem to find the best solution from brute solution. Okay, thanks for watching this video. We will meet again in the next video.